All right, so 1.8 is going to finish off chapter 1 for us. It's going to talk about statements of logic. So we're going to go over things called conditionals because that's where a lot of our theorems come from. These are your if-then statements, and they have two parts. If is the hypothesis. The then is the conclusion. So the statement typically goes if P, then Q. So if this happens, then this happens. And it can be written in symbols such as P, and then you see these little arrows that point to the Q. So those two things mean the same thing. So if you only see it in terms of arrows, you want to know that that means if P, then Q. So for part 1, we're going to identify the hypothesis and the conclusion. Remember, the hypothesis comes after the if, the conclusion comes after the then, and they are not parts of the hypothesis and conclusion. So what I would suggest is even box, also box the comma, because that is not inclusive either. And then you underline the hypothesis, which is today is the first day of fall, which comes right after the if, and then the month is September would be the conclusion, and we're going to underline it twice. So again, identify where the if, the comma, and the then are, and then whatever you underline, whatever comes after the if before the comma is your hypothesis, and then whatever comes after the then would be your conclusion. So if we shift gears a little bit, instead of being given the if-then statement, now we want to write an if-then statement. So we have to take whatever statement they give us, such as a rectangle has 4 right angles, and we have to figure out, okay, where can I split this? So we're going to split it right after rectangle, and we're going to put it in an if-then format. So you can't say if rectangle then has 4 right angles. You've got to add something to it. So for example, if a figure is a rectangle, then it has 4 right angles. If a shape is a rectangle, then it has 4 right angles. Lots of possibilities here, but obviously don't write like if an animal is a rectangle. It's got to make sense. But figure, shape, object, whatever you want to use in a general sense for that. Now for number 2, we have tiger. If a tiger is an animal, so let's split it after tiger. Well, if something is a tiger, if an animal is a tiger, if a mammal is a tiger, if it is a tiger, comma, then it is an animal. Always make sure I should be able to find the if, the comma, and the then. The if, the comma, and the then in all of your if-then statements when you write them. All right, so let's keep going with this. So it says write a conditional statement for the following. So I would pause the video, see if you can write one for A and B, and then come back and see if it matches what I have. Again, in a general sense, it just needs to be split at the same location that mine was split at. So if you're back, then basically I split it after 0. So an integer that ends with 0 is divisible by 5. So I wrote if a number is an integer that ends with 0, comma, then it is divisible by 5. If something is an integer that ends with 0, then it is divisible by 5. For B, I split it after square, just like we did with rectangle above, and I said if a figure is a square, then it has 4 congruent sides. Now, a conditional can have truth value, true or false. Something would be true if you can show that every single time the hypothesis is true, the conclusion is true. False, all it takes is to find one counterexample, where if the hypothesis is true, the conclusion is false. So it only takes one to disprove something. So an instance could be for A, so it says show that the conditional is false by finding a counterexample. So if it is February, then there are 28 days in the month. Well, we also know February has leap years where there's only 29. So that is your one counterexample that would disprove this, and you would be able to say that this is a false statement. For B, if the name of a state contains the word new, then the state borders an ocean. Well, New Mexico doesn't. So again, it only takes one to show that this statement would therefore be false. Next thing we're going to touch on is something called a negation. So the negation of any statement P is not P. And you see this little symbol here that you're going to add in front of the P. So the negation of it is raining is it is not raining. Also, the negation of it is not raining is it is raining. So you're going opposite. So if you negate a negated P, then they sort of cancel each other out. Think of like a double negative. Minus a negative would cancel it out and make it a positive. Now, every conditional statement has 3 other statements that are associated with it. The conditional is what we've been talking about. If P, then Q. The converse, what that does is it completely flips the statement. So the P and the Q flip-flop places. So now a converse is if Q, then P. An inverse would then be if not P, then not Q. So the inverse negates the conditional. The contrapositive negates the converse. So if not Q, then not P. So what you're going to find is P and Q, they're not going to be P's and Q's. They're going to be actual words. So the next example is going to show you. So it says find the converse, the inverse, and the contrapositive. So you're given the conditional. So this is your conditional already, which means it should go if P, then Q. So we see our if, we see our comma and our then. So you live in Atlanta is our hypothesis, or P, and you live in Georgia would be our conclusion, or our Q value. So the converse goes if Q, then P. So it flips it. So instead of if you live in Atlanta, then you live in Georgia, it's if you live in Georgia, then you live in Atlanta. The inverse negates the conditional. So if not P, then not Q. So if you don't live in Atlanta, then you don't live in Georgia. And the contrapositive negates the inverse, or the converse, sorry. So if not Q, then not P. So if you don't live in Georgia, then you don't live in Atlanta. The only other minor thing that you could see here would be a Venn diagram, and you've done many of these in English class in terms of writing. But if it says if Joe is a member of the Indian Hill soccer team, then he's a student at Indian Hill. So if we wanted to create ourselves a Venn diagram to help support the conclusion as to whether this is a true or false statement, we would think, okay, in that statement, what's the bigger picture? Well, the bigger picture would be Indian Hill. So that's my larger circle. Within that circle, we have a soccer team. So that soccer team has to go inside, because if you're on the soccer team, that means you go to Indian Hills. And then it says, if Joe is a member of the soccer team, then he is a student at Indian Hills, which means we make a little dot for Joe inside. He needs to be in the soccer team, which means he's also a member of Indian Hills. So this would be a true statement. Now this final theorem here, this is not a proof theorem. This is specifically only, like a two-column proof, I mean. This is only used with these types of problems. But it says if a conditional statement is true, then the contrapositive is also true. So if